Today let's explore a few more problems involving direct variation. If you recall, we had a couple unique characteristics about the model of direct variation. We used y is equal to kx, where k is a constant, also known as our slope, and we noticed that the model of direct variation graph will always pass through the origin. They'll give us values of x and y that relate to each other, and they'll ask us to find the constant, write the equation, graph, and even evaluate. So let's see how that looks. My model again, y is equal to kx. They give me my value of x and y. Let's replace them into the model. We're solving for k. One inverse operation. We find out the value of k is 4. We found the constant. Second thing, they want us to write the equation. Well, if we go back to the model and we replace what we just found, keeping the x and y variables in place, our model is y is equal to 4x. To graph, as you recall, we start always at the origin. Since my slope and constant are the same, k and slope are the same, it tells me I'm going to count up 4 and over 1. So let's start at the origin and count up 1, 2, 3, 4, and over 1. Connect your points, and there's your graph. The next thing they're asking us to do is in letter C here is to evaluate. So if our model of direct variation is y is equal to 4x, they want us to replace x with 10 to see how that affects our value of y. Well, then y will be equal to 40. This creates an ordered pair for us. When we input 10, our output was 40. If we were to extend this graph, we would find that those two, that coordinate would be part of this line. On to a second problem. Again, let's just practice one or two together. This is really an easy enough concept to grasp. We're looking at the same conditions. X and y vary directly when given these two values. My y is -6. My x is -12. I will divide. In this one, I have negative divided by negative will give me a positive. Since it's a proper fraction, I see that I get a proper fraction when I simplify. K is equal to 1/2. The model of direct variation will be k is equal to 1/2 times x. Onto the graph. Origin up 1 over 2. And connect your points. Okay, not the best straight line, but you got the idea. Last thing they want us to do is evaluate. Find the value of y when x is equal to -6. So again, we'll replace x with -6, and we'll find that the value of y will be -3. When we input -6, our output is -3. If we go to our graph and we go to -6, 1, 2, 3, 4, 5, 6, and down 1, 2, 3, you're going to see that it does fall exactly on that line. I have a couple of additional problems for you to try here. We'll see how these work. We're going to do a couple. I think I'm going to add one more to this mix. And I'm going to add, so try these. And we can have fractions, we can have decimals. We can certainly find these values. So try these 3, and we'll go over these together. Short lesson today, just as a review.